This is problem 11 from chapter 19. It's about ghosts. So what they're asking us to do here is sort of work with the margin of error before we sort of dive in and do an entire confidence interval. So anyway, let's take a look at this. So it sounds like there was a poll taken and 38% of a random sample of 1,012 adults said they believe in ghosts. So let's just take some notes. So I'm just going to say, well, the sample size, n, is 1,012, and the sample proportion is 38%. If we say that if you believe in ghosts, we define that as success. Okay, so they're asking us to find the margin of error for this poll. Okay, well, the margin of error is equal to the critical value times the standard error of p hat. Okay, so that's kind of a bunch of notation. The critical value times the square root of p hat times q hat, all divided by n. Okay, so we'll come back to this in a second. So this is going to be 0.38, and then q, remember that q hat is just 1 minus p hat, so 1 minus 0.38, so that would be 0.62. So that's 0.62. And then we're going to divide by the sample size, so 1,012. So now the question is, what's the confidence? 90% confidence. So let's think about this. 90% confident. So that would mean that there's 10% left. So 0.05 here and 0.05 here, because it would be half. It's symmetric. So the z-value, if you don't remember it, some of these you can commit to memory. It's going to be inverse norm of 0.05. And you'll find that that is negative 1.645, and you can just drop the negative. Okay, so 1.645. Okay, so if you put this all into your calculator, what you will get is 2.5%. So that's the margin of error for this situation. Okay, so explain what the margin of error means. So if you think about it, a confidence interval is just an estimate plus or minus the margin of error. Okay, so we would say something like the pollsters are 90% confident that the true population of adults that believe in ghosts is 38% plus or minus 2.5%. Okay? That's how you would answer that question. Okay, if we wanted to be 99% confident, will the margin of error be larger or smaller? Okay, so if we want to be more confident, we would have to, think of it this way, we're trying to trap the true proportion. Okay, so if we want to be more confident, we would create a bigger range. Okay, so then that would mean that we're taking our estimate, 38%, and we're going to add more to it. So we would say the margin of error would be larger. Think of it, sometimes I'd say, think about a basketball player, that they're shooting, there's this hoop, and they're out here somewhere, and they're shooting the ball, and they're going to try to get it in this hoop. Well, they have a certain level of confidence that they can make it. But what if we made the hoop bigger? Then their confidence would go up. So that's the same thing that's going on here. Is if we make the margin of error bigger, we're more likely to catch the true population proportion in our estimate. Okay, so now they want us to find the margin of error for this, for 99% confidence. So in that case, we're going to basically use the same computation. Okay, it's still the same computation, but our confidence, our critical value changes. 38 times 0.62 divided by 1012. Okay, sorry about this electronic pen, but it's really hard to use. Okay, so we have to go back to this diagram, and now we're much further out, right? We're 99, so they wanted 99% confident, so there's only 1% left, so this would be 0.005 and 0.005, right? 0.01 divided by 2 is 0.005. So then Z star would be inverse norm of 0.005, and that is 2.576. So same number here, just multiplying it by something bigger, right? Before it was 1.645, now it's 2.576. So the margin of error is going to be bigger. And it comes out to be 3.9%. Okay, in general, if all other aspects of the situation remain the same, will a smaller margin of error involve greater or less confidence? So in this case, it would be less confident. Right? Because 90% we're less confident. We're only 90% confident. We have a smaller margin of error, so we're less confident. Now, what they're not asking, that's important to realize, is which estimate is going to be more accurate. 38% plus or minus 3.9%, or 38% plus or minus 0.2%. So here, with the first case, with 90% confidence, we're more accurate but less confident. Here we have a wider range, so we're not as accurate in our estimate, but we have more confidence that we're correct. So those are the trade-offs. Okay, that's how you do this problem on ghosts. Good luck.